Okay, there we go. We have a microphone. Okay, alright, I think we are good to go. Hello, welcome back. We're back to our regular programming where we'll be doing paired programming. I have with me today Timo, who is actually with us.
Going to be a real paired programming session.
Yes, actual paired programming session. Before it was remote, but now we actually can sit next to each other, which is awesome. Alright, so today we're going to talk about something that we have been talking internally, but also with the community for quite some time, and that is about the Bloom filter. And the reason why, we're going to go into what the Bloom filter is, but also talk first about why it is important to have, or why we're thinking about implementing a Bloom filter. And that goes to how we transport our data over the CDP network. So something you know about LoRa is that there is a cap of how much information you can send per packet, and that's 256 bytes per packet, and that's transmitted as a stream of bytes. So whenever you put send data and put information into your payload, it is turned into bytes and sent over the network. But it's not just the payload data that you're sending when you hit send data. There's also a bunch of other stuff that we use on the back end to make sure that the data gets through properly, as well as also we can tell where that data is coming from, and that is part of the header. So in this image right here, you can actually see the setup of how we structure all of our data packets. So to save space, since we only have 256 bytes, a lot of it is based off of its position. So we have cut away a specific number of bytes for each different part of the header. So the first part is the source, or the device ID, that the sender ID of the message. So whatever duck device has sent it, its ID will be up there, and we reserve 8 bytes for that. So no matter how big we specify that the message ID, the duck ID needs to be 8 bytes long.
Yeah.
And so we'll know the bytes from 0 to 7 is the duck ID. Then the next part is the destination ID. So this is where you'll set your target. So in an event where you want to have, if you want to have two-way communication, this is going to be important, where we need to know where this message is supposed to end up. Which right now we don't use. It's kind of reserved for future functionality, but something to keep in mind where we do reserve that amount. Most of the packets will just have that as just like a null value, which means it's going to the pop-up. So the next part is the message ID. We reserve 4 bytes for the message ID, so it's going to be a unique ID each time. Then you have our topic, so we know what kind of data this is, so whether that's the status data, which is the general topic, or if it's location, like GPS or sensor data. Each of those has a specific byte assigned to it. The next part is the offset. So one of the things to keep in mind, there are 2 areas of the pack which have variable lengths. So far we've said, okay, the device ID is always going to be 8 bytes. The target is always going to be 8 bytes. The message ID is always going to be 4 bytes. But there are 2 parts of this packet that are that have variable lengths, and that's the payload and path. So to account for that is we have an offset. So it tells us, okay, at when does the path start? Because we have, so you can see over here, we have the data after we have the header. So these are all header, all part of the header up until 27. Then you have the data. So we reserve 180 bytes for your payload. But that can be variable size. You could be sending a message that only has 50 bytes in it. So that means that the path would start at what? That would be 77. And so we need to know where that is. So that's what the path offset tells us where to look for the path. So the next is the duck type. So we know what kind of duck sent the message. Then also we have the hop count, so we can keep track of how many hops the message has gone through. So every single time the message hops from one duck to another, that this value is incremented by 1. After that is the CRC. So CRC is basically what. So there are two different CRCs. There's one CRC that LoRa does, and so maybe back up. What CRC does is it will run an algorithm on the series of bytes, so whatever was sent, and it will generate a value, and it will use that value to check, hey, is this different from what it's supposed to be? And so that way we can check to make sure that there's no corruption or lost bytes. We do a second check on the payload just to make sure that the payload is completely intact, because we have seen that the CRC that comes pre-baked with LoRa can be a little bit strange, and we'll end up with corrupted packets, even though they shouldn't exist. So this way we have an extra layer of security to make sure that the packet that was sent is completely intact. As we mentioned earlier, we have the data, and now what really relates to the whole conversation of having a Bloom filter is this last part, which is the path. Now, the path exists to make sure that when a message is sent in the mesh network, when the message comes back, that message isn't repeated if a duck has already sent it. So how we do this is that when a duck sends, so when you have duck A sends a message to duck B, when duck B sends relays that message, it will leave a digital signature in the path. So you can see in the path we reserve 48 bytes, which means that it can hold up to 6 hops worth of data. So when the duck C gets the message from duck B and sends a message, duck B will get that message that it just sent, that duck C just sent. But it'll check the path and it'll say, oh, well, my name is inside the path, therefore I shouldn't send it. This way we don't end up with an infinite loop of sending messages.
And this has gone through a whole iteration of different things. We started off with, naming our ducks with as many characters as we wanted to, and we're just literally reading the path. So we had duck IDs that were 2 characters, some of them were 12. I think, through help of the open source community, we came to a conclusion that we need to define a structure of what the data looks like. So that's 8 characters, and then we can preserve 48 bytes. But as you can already tell, the whole purpose of this stream is researching different ways of leaving that digital signature. Because if you are limited to 6 hop, that means you're only able to have 6 ducks in your network. Of course, the goal of the Gozus protocol is to have great big networks running more and more ducks to the Gozus network. So, and it also takes up a lot of bytes because you need to offset, you need the duck IDs themselves, which is already 50 bytes of data you want to use for something else. Mm-hmm. So what we're researching today is actually trying to find a way, and it was brought up to us by the open source community as well, is the Bloom filter. And I think Nick will later go into what it actually does. But I think what is important to know for anyone that's watching, we're trying to use the Bloom filter to figure out how we route data through a network. It goes from A to B, and we want to make sure it doesn't go from A to B to A to B. We call this duck dosing. When ducks keep sending data to each other, we never know if it already has been there. So you want to tell the duck, hey, I've already been here, just do nothing with the message. Because that's the thing about mesh networks, they don't go anywhere. They will come back to you, and they will keep repeating if you don't tell it that you already have seen this. So
yeah, this is we have one type of mesh network where every device broadcasts, and that's why we run into this issues where that every single time a message is sent, any duck that is in range will receive that message, which is a a good thing in a way where you'll end up with duplicates of data, so therefore you have a higher chance of data getting through to back to your backhaul, which is our Papa Duck. However, you also run the risk of where you have increasing too much traffic. So that's where it comes into, not only are we managing our packet size, or how do we be as efficient as possible with the amount of space we have per packet, but also managing traffic so that there's not so many messages going on the air that you can't send any new messages. So if we're able to eliminate we hope to use a Bloom filter, which would eliminate the need to have a path, because it would create an easy way to have a lookup that is very fast to figuring out, did we already send a message.
Yeah, and please bear with us. Bloom filters are very complicated. We've been doing more research on this over a long period, but it's not that simple, especially implementing it. So this stream is going to be pretty technical. We're going to dive in what the Bloom filter does. But please ask questions or reach out to us later if you don't follow along, because it's definitely in very intrigue system. It's complicated, but once I think Nick will do his best explaining it. Once you understand it, it makes a lot of sense on how to use it. So.
Yeah, so essentially what a Bloom filter is kind of what you would imagine if you were to have a list of all the messages you ever sent, right? Where you have like, okay, I have an array and I'll store every message ID in there, which you could do, which we could do. However, this is very long and also could take up a lot of space, and also on top of it, it's not the most efficient way that we could probably do this. Using a Bloom filter, we can store a lot of data, so a lot of messages, be able to quickly look them up, and also have a good probability that we won't send a message that we've already sent before. So how we do this is we have a Bloom filter bit array. So where it's basically where we turn, as you can see here, it has like a bunch of zeros and ones where we're just turning things on and off. Now, when we do get a message, what we'll do is we'll take the message or the message ID or the payload, and what we'll do is we'll put that through a hash function, and that hash function will turn the whatever we put into a number, and then that number is inserted into the Bloom filter. Now, how this works is that when we get that same message ID back and we put it through the same hash function, we'll get the same number and we'll say, oh, okay, well, we already have that. We've already seen this one before. And then, which is great. However, there is a little bit of risk where, since we are putting it through an algorithm, there is a chance that we might end up with the same number. So we could put in A and we get 5, and we can put like A, B, C and also get 5. But there is a way to calculate what your chance of this happening. And you can actually mitigate this by adding more hash functions. So instead of putting it through just one hash function, we put it through 2 hash functions. So we'll end up with 2 different numbers, and we'll put both of those numbers into the Bloom filter. And so that way, when we do a check again, we can say, oh, is both numbers the same? Or is it, or is maybe one the same and another one different? This is something that has been a lot of research from one of our community members, Gozus, a while back, did a lot of testing, and where he was finding that, using a couple filters, we were able to have where, this event where we get 2 numbers of the same would be I don't know, it was like only over 4 million, 1 in 4 million or something like this. It was a very rare chance that something like that would happen.
And maybe we can recap the Bloom filter real quick. Imagine I'm packet A, B, C, D. I'm the origin duck, and I send this into the world. Nick will receive my message with the message ID, which is ABCD, and he puts it through a hash function. Out of the hash function, number 10 comes out. That's what the hash actually is, number 10. What the Bloomfilter bit array will do is it will only say, it will put number 10 into the bit array, and then it's so it knows it's there. When my message travels again, and it would end up at Nick again, he puts it to the same hash function. Number 10 comes out again. The only thing that the bit array says is it 1? Is it already there? Or is it 0? I have not seen this before. The whole purpose of this is that if I would travel around the network hundreds of times, Nick is going to say after the first time, okay, I've already seen this, don't do anything with it. And as you can see, it's all this data will be stored on the duck, and you don't have to store this inside of the packet, because the only thing that the duck needs to do is take ABCD, puts it through the hash, and say, have I seen this or have I not seen this before? And what Nick was just describing is if you put the message ABCD through the hash, number 10 comes out, but maybe ABCD also is number 10. So what you can do is you can put this through 2 different hash functions, which has 2 different results, and it's almost a double certainty way of saying I have already seen this, yes or no. And based on those functions, we can make decisions on what do we do if we, for the second time, did not see it yet on one or the other. But I think the whole purpose of this is just storing all the ducks that are in the networks on the duck itself. And there are a lot of technicalities that will go after this, because one of the things you have to figure out is how long does the duck store those hashes that they have seen yet. If you never delete them, it's very possible after maybe months of running your network, it's very probable, the probability is high that you're getting a lot of different hash results. Mm-hmm. So one of the things we're going to figure out is when do you delete the Bloomfilter hashes, because there's also a probability that the duck IDs are random. The mesh IDs are randomly generated. That those are the same. It's maybe once in 100 million, but there is a possibility there. So I hope everyone understands. It's a difficult subject, but it will really help us make this more efficient, and it will be a lot better for our system.
Mm-hmm. Yeah. So, also something that going back to Gozu, he came up with this interesting idea where you can have a smaller Bloomfilter, but you can have 2 of them. And you can just have when one fills up, you make that a read only, and then you start the second Bloomfilter with a different seed or different kind of hash function, and that way you can minimize the amount of processing that you need to use. So he actually built this test over here that's pretty neat. If you want to check it out, it's actually a really very simplified version of the Bloomfilter. So if you want to check it out, what he did here, it's a little bit, for me, I'm still understanding certain parts of it. But also we have another one where we have this library here, this Bloomfilter library. That we're actually going to try using and implementing today during the stream. So this one's actually done by Arash Partau. We're going to try implementing this, but we might go back in the future.
Yeah, it's definitely new, pretty difficult implementation, but I think we're going to just make a start on it this week, and hopefully we can do some research over the upcoming week, and then next week on the stream we can keep working on it, because it will really help anyone in the CDP to just store more data in the payloads, which is LoRa is limited, but if we can free up 50 bytes of space, that's going to help us a lot with the future of this of the Cluster protocol. So. What's the first step?
All right, so here, so actually something to note, if you want to check to see where the most up-to-date information about how our packet format is in cdp packet.h. It's in the source folder. So definitely check it out. That's where we were looking at before. You also can see here are some of the reserved topics that we have. And then also, so here's some other topics for different kinds of stuff. So if you want to send an alert message or a sensor, you also see in a Papa-Duck INO. Let's see, I think it's right here. So where we take that to and change that into an actual string, which we used to upload. All right, so let's get started. And so first of all, we're going to get full origin master. Let's make sure we are up to date. Okay, and so then what we're going to do is get branch -b stream 9. Ooh. Wait, how do I? Someone just doing this wrong. How do I create a new branch?
Right. Good checkout.
Oh, checkout. Yeah.
Took me a second to.
Yeah. Checkout -b. There we go. Yeah. Okay. It's been a moment. All right. So let's get started. So I've been looking at this one here. So what we're gonna take, so we've only got one here, this bloom filter here. So we're gonna actually take this, copy all of his.
You're gonna use it as an external file.
Yeah, so we're going to include this as is into, so we're going to create a new, and put this in include, so that anyone, new file, and this is, what did he call it?
Bloomfilter dot.
Underscore filter, okay. See, new file, bloom underscore filter .hpp. Alright. So I'm not sure if this one will compile in Arduino, but we'll give it a try. So now to how to use this, if we go back here.
So the thing with the bloom filter is you kind of have to tell it how much you're going to store inside of the bloom filter itself. But that's an unknown variable for us because we don't know how many packets will travel through the bloom filter. It could be 1 or it could be 10,000.
Well, from Gozu, he did from his testing, he said that we only need a bloom filter that would fill up to 2,000 messages, and that would give us enough. And so also on the rate of messages that we are currently sending, and using 2 bloom filters, so that's like up to 4,000 messages I have gone through, that would be enough where we should be safe from the messages coming back and getting DDoS.
Yeah.
So we're going to have to do our own testing as well, but we're going to have to try this out. So why don't we now, what we're going to do is we're also going to create an example where we're going to try using this. So let's see. So this is how we implement it. So when we start, we're going to have to create bloom parameters. Okay. So let's see. Where do we want to implement this first? So what we could do is we could put the, well, probably where we want to put this is in duck radio. So if we put in relay packet. So we want to do a prepare for relay. That I think is that duck packet. Yes, prepare for relaying. Okay, so here in prepare for relaying, if I remove this, a little easier to see. So in prepare for relaying, we are doing what we had talked about before, where we have where we're going to check the path. Let's see, is it? Wait, here. Path, yeah, here, path section. Index of, wait, where is it doing? Check path, let's see. Path. Offset. Data buffer.
Is there reset the offset?
So this is this is already adding it too. So where are we doing? Checking path. Integrity. Position. No, that's for adding. Where are we doing check path? Or is that around on the duck level? No. So wait, so it goes to...
We're looking for where do we check the path?
Yeah. Let's see. Handle receive packet. Duck radio, yeah. Read receive data. Oh, me, it's in read receive data, but it's in duck radio. Duck radio. Here. That's read. Mesh, packet length.
In duckpacket.cbp we have the
Duck packet.
on like line 50 we have the packet already seen. Ignore it. Max hops read cannot relay packet. That's what we're looking for.
Let's see. What we're seeing. Alright, yeah, here. Pass string. Yeah. Okay, so index of ID. So yeah, here we go. So yeah, so it takes the ID of the duck. So this is duck, we'll say duck B, and says, okay, is duck B inside the path? Yeah, so this was in, yeah, it was in relay. I just overlooked it. Okay, so yes, that's what we were talking about before. So what we want to do, so what we can do here instead is maybe this is where we shall put in our put our check to see if it's in our
Yeah, of course the path will eventually be gone. It will be out of there, but I think we can start with just
and so include, we want to include Bloomfilter. Okay, so so we're going to need to initialize in here, right? We're going to need to set up Bloomfilter. So we can create a function here. void duck packet setup. I'll just put BF for, okay, we'll make it more readable. Bloom filter. Okay. Yes, I know it doesn't exist yet, but if we go back here, so what we need to do is, let's just go and go from their example here. And bloom filter. So filter parameters. Oh, no. Here. There we go. Oh, and we don't need this here. We can do serial.print.
Yeah, we'll make those loggers later.
Yeah, just for now. Alright, and then we don't need a return just yet. Alright. Alright, cool. So it recognizes it. Awesome.
Yeah, just the methods.
Yeah, so the only thing is that we need this outside, right? Because we need to be able to access the filter.
Yeah, on every single duck.
Mm-hmm. Let's see. Are we able to do? Maybe what we can do equals, what is this? And what's the best way to do it?
You want to be able to access filter on every single duck?
No, so we just want need it to be accessible here because we're gonna do all of our bloom filter stuff here.
Yeah.
But it needs to be accessible by other methods, right? So it has to be accessible by relay. Cause we're gonna put our right here.
Can we create it outside of the method?
Bloom filter stuff here, right?
Mm-hmm.
We're gonna put our bloom filter stuff there. But when this needs to be accessible by there, best way, we just make, let's see, just put this. We have in our, let's see, where's our duck packet.h?
There it is.
Oh, okay, I have it right on that. Okay, so what we'll add in here, is our, we're gonna have to include here.
Filter.
Okay, and then this is gonna be So if we do that, and then we put undefined.
That makes sense.
Might get a redefinition error, but we'll leave it like that for now.
At least when exit for now.
Mm-hmm.
And I think also we might have to change.
Yeah, we'll also change that this can be, change all this stuff here.
Yeah.
But right now we're just going to test if it works. All right, so let's see if we can compile. So we'll just put that there. And so while that is compiling the sketch, we're going to continue working here. Okay, so now we have our bloom filter. So now we got to start adding stuff into it.
And what's the example of stuffing things inside of the bloom filter?
Yes.
Insert some strings.
Mm-hmm. So just insert from string list. So actually,
they have an array of.
So they insert some numbers. They'll insert some strings in there. Okay. Yeah. Why don't we just try this?
And instead of maybe doing an array, we can test it. There's some questions there.
Let's see. So from Mia, in the return, it's already there. Can't return 1, not return 0, return 0, and it hasn't been there. Do some processing. Did you include other class from the current class?
For the first question, we can probably do it direct. We don't even have to return anything. We can just do drop packet or relay packet.
So in the return, Mia, are you talking about the return that I deleted earlier? You're talking about the return that was here when it failed? Actually, let's see. It's still compiling. All right, so it seems like that's working. Because there'll be a return here right now. I had to remove the return because I made this a void. So, right there we can return 1. If not, return 0. Oh, okay. Yeah. So if the so we'll put that return back here, but also when we for here, so we actually return. So what we're doing is we're replacing this part right here. So if it's already been seen, we're going to return. So because this one actually returns a bool. So what we'll do is we'll return. If it's already in there, we'll return false. And if it's not in there, we're going to return true. So basically it's the same thing as you said, where it's 1 or 0. So that's what we'll be doing. Okay, so let's see here. Let's put insert into.
And just the class is called filter, so you just call it and you do filter.insert, which is.
Well, the class is called Bloomfilter.
Sorry, and the method, the object is called the filter.
Yes.
So that's easy. That seems straightforward. Filter.insert, and we can just, instead of passing an I or string list, we're gonna pass in, of course, the message ID later. We're gonna just confirm if it. Are we able to see what's inside of a Bloom filter?
I don't think you need to. I mean, we could probably, what we could do, so this one is the library. I don't know if there's where we can actually see. So with Gozus, we would probably be able to see the output of what the hash is and be able to print that out.
So to verify if it works, we're gonna pass the value in and
then query it.
Okay.
Yeah. So. Okay, so those have been inserted. So let's see, did we get any errors? Okay, so we did get an error.
Yes, fun.
Oh, well, that would make sense. So what I did not
create the class for it.
No, not the class. Did not
the method.
tell that the method exists. So what we're doing, it was a void setup
Bloomfilter.
Filter.
And it's a void, so easy to do.
Okay, there we go. So what I think, so other than that, it looked like everything was fine.
Surprisingly enough. So an HPP file is kind of like a .h file and a CPP file combined. I think we could split it up.
I'm not sure. But so we'll see.
Also, we need to make a decision if we want to include the full library or just take the code. What kind is allowed with the license.
Let's see here. And we want this for the health tech. All right, so let's just upload this. We want to open a different example. So if you installed your CDP library into your Arduino libraries, you'll have access to all of the examples really easily. So just a fun fact. So we're just going to put a mama duck here. And we're going to upload this one. All right, so I'm uploading this to a duck, and we will see, hopefully, it should just work, but I did not put any outputs here. I'm going to put serial print.
And we're just passing in these values right now. We're not doing any other.
So we see a little output. So I have another duck that is going to be sending messages constantly. So we should be able to see here. Actually, I'm going to change this so it's not verbose. There you go. You don't need to see all the stuff. It's a little bit slower. Okay, so now that that's going, so now let's put in the query. Let's see. And okay, we can do this as well.
Missed the.
No, that's
it's because it's already in the method.
Is I think this is makes it an anonymous function. I think I'm not sure. I'm not 100% sure of doing it that way. But anyways, we're just gonna plop this in here. Let's open this again. All right, so I gotta replace these guys with the serial dot.
Easy as that. There's some comments you might find interesting.
Great scope. Okay, not a scope. Oh, okay. So yeah, it's a.
That's a good comment.
Yeah, thanks, Rory. I think, yeah. So I was thinking of something along those lines. Okay. Yeah. Okay. I was looking at it. I assumed it had that kind of functionality, but thank you for clarifying. And then let's see in the loop. Okay, so for Mia, the loop with the current method, that's just for the size the current one, include the class from where the method included. The class, or calling the method, that way you can use the filter method. Also, you made it private. The only way you'll have access is through the method in the class. Well, I think it's fine for private, because anyways it only should be accessed within within duck packet. So yeah, so okay, what we'll do is just do print. Print okay, what? Hardware serial.
I will print a string list.
Am I doing this wrong? Well, yeah, no, but this should be. But string list is a string. Oh, maybe do I need to do it to, what is it, C string, like this? Yeah,
yes.
Okay.
Always.
Alright, yeah, this is...
We're so used to using the Arduino, like, printing.
Yeah. But anyways, alright, so actually, did this work? Alright, let's see.
Yeah, and package is build, checking, and insert into
Okay.
buffer.
Okay, so insert into...
Packet already seen, ignore it.
Mm-hmm.
What packet are you sending?
So it's coming from... So I actually have a duck with the same name that is running in my room, always constantly sending messages, and so we actually I have it collecting data, so 24/7, so we can monitor it so that the latest we can see if there's any issues going through. So here I'm also sending my own messages. Okay, so it tried to insert, but it already exists. So actually, I wonder. Okay, so it's constantly inserting into there. All right, so maybe we only want that to run
because
once,
there's no
actually.
check, there's no reading first, only inserting.
Yeah, so constantly inserting the same stuff.
Which works, which is good.
Well, we want to first check before we insert. So actually, let's not do that there. We should actually put this in that setup. Yeah, let's put this in the setup over here. So actually, yeah. Okay, so now we only insert once, and then we want to query size of, oh, and also we're going to need this string list down here. So, all right, there we go. We got the string list, and we want to get rid of that. All right. And then we just have one more here. Let's see. Let's make it happy. Special must have an integral or unscoped enum type. Why is it upset?
Plus invalid string list. Should be the same as the other string list, to be honest.
Yeah. What am I missing? Yeah, Mia, that's correct. That's I was just every single time. So this relay runs every single time it receives a packet. So I was inserting every single time, which you wouldn't do, but we're just kind of just testing to see if things work. All right, I'm just gonna comment this out just for now because I'm really curious to see if we're actually able to get stuff out of this. So
reading it, yeah.
Yeah, so we're just going to upload this again.
And by the time it's uploaded, we can research.
Mm-hmm. So yeah, so I have another one of these mama ones. And so that's why, so this is also a good example of it checking the path. So it says, okay, my duck ID is mama001. All right, now let's check the path because we got the path from the data stream. And so it says, okay, is mama0001 in there? And it is because the device I have in my room has the exact same name. And so that's going to be already in the path. So this is also why it's important to make sure if you're setting up multiple devices that you change this from 1 to 2 or you increment or however you want to make it, because otherwise if you have 2 of the same name, they won't be able to communicate with each other. They'll start throwing out packets. So something to keep in mind because it's happened before. All right, so that's uploaded. Now let's see. Oh.
Interesting.
What did I do?
It's going wrong with the prints.
Already seen. Okay, so this is what I wanted to see. Was Bloomfilter contains these things.
It's not hashed, is it?
Huh?
It's not hashed.
What do you mean it's not hashed?
Because these are just the values of the strings.
Well, so I these are the values that's in the string list, right?
Okay, got it.
So I said, hey, are these in there? So now we can take this to the next step here. So first, if we want to do query, vector byte. Oh, this takes the path section. So, we don't get the whole thing. But what we can do is we can insert in. So what we'll do here. So what we're going to do is we're going to take the. Let's see. Path string. All right. So the path string will be 1. So we're not going to do this for loop. We just need this filter contains. All right. So we're going to do here if filter contains, and so filter contains contains, that would be
message ID. That's duck ID.
Yeah, but we're just gonna
we're going to change it from an 8-character duck ID back to a 4-character message ID, but it's not in there right now.
Yeah, so this is a little bit hacking around. So what we're gonna get, so we want contains ID. The filter contains ID. Then we'll just do .print ln it's or we're here.
Where are we?
We're here.
Yeah, it's just we're gonna check now.
Is that the right Dr. Seuss reference? I don't know. Else, what we're going to do is we're going to insert.
So this is a very simple test right now because we don't have infinite time to just insert something that's coming from the path. In this case, it's a duck ID. And seeing if it's already there or not.
Okay, so let's get rid of that. And so then we're going to put in here serial.print and
inserting ID.
Something. Yeah, inserted ID. Okay, so. Okay.
This is what I call paired programming. Nick does all the work, and I just do comments on his
Let's see.
typos.
Let's see how. It's infinite loop. Mia, where is an infinite loop? Sorry, I didn't see. Okay, so this will be the test right here. So when we start this, the ID will not be in there. And then we'll insert it into there. And then the second time the message comes around, when we do this, it should say we're here. And it should say we're here from.
You are going to change the duck ID of the duck you're sending from, right? Because you have that one.
Well, it's not gonna matter because I'm just inserting in the duck ID.
Got it.
Because we're not checking the path anymore.
We're not checking path yet, or not.
We're just So this is gonna be a test to see if it works, and then we'll call it a day for that, and then we'll clean it up for during next stream. So hopefully
keep working on it.
Mm-hmm. Yeah, so let's see.
So I hope everyone kind of understands. Sorry, I'm not even in frame. That what the Bloom filter does. So instead of checking a full 8 character byte path ID, is like, hey, have I seen this thing? We're just gonna store them on small numbers on a device, which will make it a lot easier for us to see, like, hey, I got it or I don't have it yet. And as you can see, it's the implementation seems super easy. I mean, Nick did a really good job, but the hard part is going to be figuring out all the double Bloom filters, the reliability, all those checks. We're here.
So we're here's, but let's see. Let me just reset this. All right, so I'm gonna set up okay. Wait here. I'm just gonna. Clear output and reset.
So it starts with the word here. So the filter already has that ID.
Yeah, so that's not right. Because we should get this one first.
And there's no way for it to be stored on the device even if you reset it, which is interesting.
I mean, we did insert some stuff here. Oh, wait. It could be because we just... I mean, this shouldn't be the issue.
No, because you're not inserting the ID.
So, let's see. Let's upload this again. It was Mia. Oh, okay. Alright, thanks, Mia. Yeah. Alright, so we'll see. So, okay. How would it... So, yeah, so when this runs for the first time... Inserted ID. Unless I missed something in the... Alright, so it's writing. Almost done. Okay, so now let's see. Set up okay. Right here.
Oh, we have no statement. If it's...
No, the statement's there. So, let's see. Did I miss it somewhere?
There's a couple comments we scroll down. Overridden by each packet. Yeah, so I did make it here. So I have the Bloom filter here. Let's see. Written by each should be a member. Yeah, so I have it there, which is I'm a little confused. So and so also but duck packet might not be an instance. Duck radio has duck radio, we have an instance of duck radio but not of duck packet, but I don't think that's gonna create an issue. And then also we only... Oh wait. Do I never run setup? I don't run setup Bloom filter. Okay, there you go.
So filter,
It's
but
just
but it. I know. Okay, well, I guess there's two things here. So setup Bloom filter is never run, so that's one issue. But then also filter, though, if I remember correctly, in the library it does have default values. So as we go to the HPP, let's see. So I think they had in. Oh, I mean, he doesn't. So. So I think this is like default ones, but I think it might be a problem. Oh, let's see. Oh yeah, so we do have this here, but if I get rid of that,
because we also have the Bloom filter temp, which is the other. This one filter is temp.
okay.
That's the one we use.
Okay, so maybe that was creating issues.
And Mia says it's private, but I think.
But it's private. It's
fine.
private. It's private to this CPP file.
And it's the only place we're going to use this.
Yeah, the only place that's using it. So, all right. So we'll see if that changes it. Anyways, it takes a moment for it to. So let's see if we do. So I need to call this somewhere. I don't call this, right? Yeah, I
mean, it does run.
Yeah, but I think there's definitely
Because
something wrong. So I can maybe here just do.
It should be outside of the relay even. It should be at receive.
Yeah, so maybe I can call it from duck radio. Let's see when I set up. Yeah, so here. Let's see. Yeah, so duck packet's in here. So maybe I just do when I do set up radio. I just put in here like duck. Oh, but what? Let me see. Duck packet. Okay, yeah, so I can should be able to. Can I do? Oh no, I have to create an instance of it.
It's not there.
How do I call that? Let's see.
You just want to be able to call duck setup.
Yeah, I just wanted to call duck setup. Do I call duck packet anywhere? Okay, it doesn't do anything. So if I can just do duck. Oh, this is like duck packet. Temp dot setup. Bloom filter. That's not. Okay. All right. So let's see what came out from.
Just test it.
All right. So just.
There will be a lot of testing over the upcoming weeks for this.
So, all right. So we're just gonna put this one. Okay. So let's try. It might be just that we haven't done the setup function, that it's not working properly. So okay. So I think this should work, even though this is like looks so bad. But if I create a duck packet object, there shouldn't be anything in it. So. Alright, so let's see.
Because at the end, setup Bloom filter should be called ones instead of setup radio.
So in setup radio, runs only once, so this should be not a problem. All right, it's uploading. This is like the most annoying thing about working with hardware is that.
The
Okay, so setup. Okay, so it should have been.
Same thing.
Still saying we're here.
That means that the reading from the Bloom filter is not correct because we specifically say if the ID is in the filter, say we're here, and it says it is. So.
Yeah, let's see.
We have to figure out why it says that ID is already inside the Bloom filter.
Yeah, what? Why is this not working?
There's our instance. There's our parameters. That's fine. Which is like I like how they set up the parameters. To be honest.
Let's see, maybe what we do, we should just check. I'll do the query. Let's see if. Wait, but also I'm not seeing insert into Bloom filter. Why am I not seeing that? Oh no, I wasn't there before.
Wasn't there? Yeah. Can we print whatever we call from when we type the word here? Can we print whatever it is in there?
So let's also do filter dot insert. Let's do this. Let's just do the same thing we just did over here. And maybe instead of into filter, we just do this into temp. There might be something wrong with the. And let's put.
Maybe it says there's no return in our if, so it just keeps looping.
No. That should be fine. Let's see. Insert ID, and then if I want this to be temp, and then if temp. What is it? Is it contains? What was it?
Contains.
Yeah, it contains.
We might have to read up on that method though.
Alright, let's see. Serial dot print ln. See here now. And then what we want to do is this exact same one before we insert.
I'm gonna be so confused where we are when you say I'm here and we're here now. Or logging is gonna be a lot better in the future, of course.
Is it bad that I just put serial prints everywhere?
No, it's not. It's how you debug, but not here. We already have a couple of those. That should be fine.
Yeah, let's see.
Not here inserting or something. Okay. So
Alright, there we go. So it's easy to see.
Exactly.
Alright.
This is welcome to Nick's coding experiences.
Yeah, so now we gotta wait. I wish I could just like run.
Yeah. To be honest, it did became faster with the one. It is a very slow process, of course. We have a lot of libraries, which we're gonna improve.
Yeah, no, but this is good. Just put serial prints everywhere. Yeah.
And that's why we have people like Amir and Gozus going into our stuff and actually making it work.
But if it was infinitely looping, well, we have I++ here.
It's ++I, but I think in C++ that doesn't matter if it's I++ or ++I.
it's okay. Well, let's just see. Okay, so it worked.
Okay, the inserting works.
So I think what's happening, there's a problem when to create the bloom filter, right? We need to put in these parameters. And I think what was happening, this part right here is just not working at all, which might be reasonable, but this works. This one works right here, so we can confirm that it does work. It's just that we need to figure out how to make this so that it's accessible to the other functions down here. Right. So
I think that's a good what we talked about earlier. We need to figure out our inheritance for the method. Declare it once, use it everywhere, and probably figure out how to set up Bloom filter once, have access to that.
Yeah, so I think this. So for now, we confirmed that hey, we've got the Bloom filter into the CDP. We know what we want to do. The next part, what we're going to have to do is just to figure out how to get it so that it's set up properly. We might have... So I'll have to look and try some things, but see if we can properly get the setup Bloom filter, because for other people might want to set it up, but maybe we just have some hard-coded ones for now. That we know will work. That might work better for others, anyways. So next time we're gonna work on initializing the Bloom filter better, but we've already confirmed that it works. So I think we're gonna cut it for today. Thanks everyone for joining. Thanks Mia and Rory. Did I pronounce your name right, Rory? Rory Olsen.
Yeah, it's good to have some live feedback. It's new for us. Bloom filter is difficult. We're not even close to it, like getting it implemented. There's going to be a double one at the end, so it's even more work. But yeah, thanks guys for being live with us, because it really helps us to do like the live debugging and if we overlook something. This code will be up online as well. It will be on our Project Owl fork from the CDP. Branches stream number 9, and there you can see all the code. It won't be cleaned up yet, but I feel like we can work on together, and everybody can chip in if they want, and we will be working on this over the upcoming week. So
stream 9. All right, and then I gotta git push owl stream -9. So so you can check our owl fork for all this code if you want to check that out.
Yeah, and we appreciate all the questions from anyone.
Yeah.
So.
No, and it's it makes this a lot of fun. So that we could. It's a pair programming. It's supposed to be a for everyone to have an active discussion while we're working on these problems, and hopefully you guys watching helps you understand the CDP, as well as also bounce ideas with us. It doesn't have to be related to exactly what we're working on. So this is just a way for you guys to communicate with us or ask why do we do certain things, or how certain parts of the CDP work. We wanted to create a place for that, but also at the same time, if people don't know what questions to ask or know what they want to do yet, they can see what we're working on live. So this is a lot of fun. Thanks for everyone for joining. So hopefully we'll see you next time, and we'll see you in the Slack. All right.
See you everyone. Bye bye.